Hello guys, welcome to the Senior High School Mathematics Forum. I'm taken by Stephen, and we are going to look at differentiation from first principles based on trick. And this is our last video on differentiation from first principles, because looking through your syllabus, your curriculum, I realized that you don't do differentiation of logarithms and then exponents, exponential functions, logarithmic functions. So we end it here with first principles by solving these three questions, because time will not permit me to solve all the six questions. So I'll only solve the three questions and give the three to you as an assignment. If you can't, why not just on the comment section comment there that you couldn't, so that I will drop my number there. You see me one on one and I'll solve them, send them through WhatsApp to you. And then don't forget to subscribe, turn, turn on the notification bell for more posts, and then share. Okay, let's begin by solving the questions. So we'll say solution. And I can remember at the right beginning of differentiation from first principles, I gave this particular one to you as an assignment. I hope you have solved and then you knew the answer already. It was minus sine x. When you differentiate it, you get minus sine x. So that is the answer. So let's move on. To differentiate it, you need the steps, though, to those who couldn't. So now we'll have it as, and to those who didn't even watch the first video, we'll have it as quoting the first principles down. Have it as f prime of x is equals to lim. Always bring this one, always bring that. Lim as h approaches 0, that's limit of h approaches 0 of the whole expression, this whole expression, f of the expression x plus h minus f of x, that one all over h, then bracket close. Have you realized that? So that is how we do it. That is how we do it, guys. Then what we will do is that we calculate this differently by finding f of x plus h, and then h. Have you realized that? So guys, in doing so, we will have, but our f of x says that what is equal to cos x. Have you realized that, guys? We are differentiating this particular function as I showed you earlier on. So we'll have f of x to be equal to cos x, that is this one. And then we'll have again f of x plus h to be equal to cos of x plus h. Have you realized that? Have you seen that, guys? So this is how it will be. So this is how it will be. F of x is equals to cos x, and f of x plus h is equals to cos x plus h. So that is how it will be. Thus, we are differentiating these trig functions using first principles. So now, we realize that we learned in JHS that cos of, sorry, I'm saying JHS, we learned in trig that cos of A plus B is equal to cos A cos B minus sin A sin B. This is just a compound angle that I'm showing to you. So notice that you have to take every topic in mathematics serious in order to get an A in your WASI. That is in your final exam and even terminal exams. Have you realized that? But terminal exam is more or less limited to what the teachers taught you. So you have to take that serious for WAEC exam, that is WASI. Have you realized that, guys? So in moving on, we will have this to be cos x cos h with respect to this one, then minus sine x sine h. Have you seen that? So we will now have f of x to be equals, f of x plus h, that's f of the expression x plus h, minus f of x to be equal to cos x cos h minus sin x sin h minus cos x, that is minus f of x. Have you realized that? So guys, don't hesitate, don't try to be okay. What I want to say is that I will be dropping videos of trick trick, so follow me and then get the videos of those tuitions to those tutorials. Have you realized that, guys? So now we'll realize that cos x is here, so we can quickly factor that one, bringing that one closer to this. We can quickly factor that one out. So in factoring that one out, we'll have cos x into bracket cos h minus 1. Have you seen that? Then minus sine of x sine h. Someone will say, why don't we leave it that way and we are doing it so? We are doing it so because we want to get a particular limit, basic limit that will give us a particular answer whereby we will get our differential easily. So in moving forward, guys, we will now put this whole thing into the differential equation. So we'll have it as f prime of x is equals to lim as h approaches 0 of the whole of this cos x bracket open cos h minus 1 minus sin x sin h all over h, guys. So have you realized that this will be all over h? Have you seen that? So moving forward, guys, we will now have it to be, we'll have it to be, we have to identify this can be divided by this and this can be divided by that each. So we'll have lim as h approaches 0 of cos x, then into bracket cos h minus 1 all over h, this is all over h, then minus sin x and sin h all over h2. Have you seen that, guys? So this is how it will be. Have you seen that, guys? That is how it will be. So in moving forward, we now have it as lim as h approaches 0 of cos x multiplying by cos h minus 1 in bracket all over h is still the same minus sin x multiplying by sin h all over h. Have you seen that, guys? So this is what I was talking about. This is what I was talking about. So what that is cos x dot, that's multiplying by the into bracket cos h minus 1 all over h, then minus sin x dot sin h all over h, and it's still the same. Have you seen that? So it's still the same. Now what we will do here is that we will do is that we will realize that lim as lim as h approaches 0 of cos h rather minus 1 all over h is equal to 0. Please, if you want to know all this, follow me on my follow me on my please follow me on my limits video, and you will see all this there. So we will have again lim as h approaches 0 of this whole rational expression sin h over h to be equals to 1. Limit as h approaches 0 of this sin h over h is equals to 1. But we've had our differential function, that is this thing rather, the gradient function or the first differential to be equal to cos multiplying cos x multiplying by cos h minus 1, that one all over h, then minus sin x multiplying by sin h all over h. This is what we've had. So what we will do is that is lim of that, lim of that. I have to always bring that. I do forget about that one, but if you see in a particular video that I have not brought it, meaning you have to bring it, because man is to error. That is, we all make mistakes. Moving forward, taking lim, it will now be like this: cos x. Have you seen that? Multiplying by lim as h approaches 0 of cos h minus 1 all over h, then minus sin x multiplying by lim as h approaches 0 of sin h over h. Have you seen that, guys? So we quickly substitute 0 into here and 1 into here. So we'll have it as 0. When we substitute 0, we'll have cos x multiplying by 0 minus sin x multiplying by 1. So guys, we'll have minus sin x. So if you differentiate cos x, you get minus sin x. That is the answer. So that is our first differential from first principles. Have you seen it? Minus sin x. So let's quickly solve the second question, that's differentiate sin x. So we are done with this one. Now let's do with this one too. So we say, so you join me, like you download or watch my limits video to get all these basic concepts, these basic limits there, and then concepts about limits before you can solve this. So now we will have solution. What does our first principle equation say? It says that f prime of x is equals to lim, always bring that one. If I don't even bring it, meaning my eyes skipped that or I forgot, so you have to bring it. Lim as h approaches 0 of f of x plus h, that's f of the expression x plus h, minus f of x. Have you seen that? So I'm just doing it based on the three basic ratios, so that you do that for their reciprocals. Guys, have you heard? Because time is not there. If you can't, as I told you earlier on, do so all over h, so that I'll get them for you. Have you seen that? So then our aim is to differentiate the function f of x is equals to sin x. So we say f of x is equals to sin x, and then we also say f of x plus h should be equals to sine x plus h. But guys, in trick, if you haven't learned it, then I'm to drop videos about that one. I will soon drop them so that you check them out. So in trick, we have sine a, sine of the expression a plus b to be equals to sine a cos b rather, sine a cos b plus sine b cos a. Have you seen that, guys? So meaning that our sine x plus sine of the expression x plus h will be equal to, someone would have said sine x plus h plus sine h. It isn't so. We don't do it that way here. This one is a compound angle, so you check that one out and avoid doing so, sine x plus h sine h. No. So that will be equals to sine x cos h plus sine h cos x. Have you seen that, guys? Then we now find f of x plus h, that's that expression, minus f of x, which will be equal to sine x cos h plus sine h cos x minus sine x. And as I told you earlier on in the first question, when we were solving the first question, you have to factor the common sine term out in order to get the basic properties of limbs and then substitute their corresponding values there. So this will be equal to, factoring sine x is here too, so factoring sine x out, we will have it as cos h minus 1, sine x multiplying by cos h minus 1 plus sine h cos x. Have you seen that, guys? So now substituting this into the function, the first differential function, or the first principles equation, lim as h approaches 0, guys, we will have it as sine x bracket open multiplying by cos h minus 1 plus sine h cos x all over h. Have you seen that, guys? Then we will have it as, moving forward, we will have it as equal to lim as h approaches 0 of sine x multiplying by cos h minus 1 all over h plus cos x, because multiplication is commutative, multiplying by sine h all over h. I hope you've learned that commutativity, associativity, closure, and all those properties, distributivity. So we will now have that to be equal to sine x multiplying by lim of h approaches 0 of the expression cos h minus 1 all over h plus cos x multiplying by lim as h approaches 0 of sin h over h. So as I told you earlier on that this one is 0 and this is 1. If you want more knowledge on that, you watch my limits video. So now we will have it to be equals to sin x multiplying by 0 plus cos x multiplying by 1, and this will be equal to cos x. So when you differentiate a sine function, you are gonna get a cos function. Have you gotten it? And when you differentiate a cos function, you are gonna get a negative sine function. So this is our answer to that question. So now let's move on. To solve our third question, and that will be all, because I don't always want the videos to get to an hour. So these are all. First video has been posted already, but these are yet to be posted. So these are adding this to the first videos. The first video will be 3 videos on differentiation from first principles. And I realized that you don't do differentiation of logarithms and then that of exponential functions. So we stop here. So moving forward, we'll quote to solve the third one, we will quote our first principle equation down. That says that f prime of x is equals to limit as h approaches 0 of f of the expression x plus h minus f of x all over h, that one bracket close. So have you seen that, guys? So this is what I'm talking about. So when you get this, you now move forward. You move forward to find f of x, but our f of x was equal to tan x. That was the function we were going to differentiate. So now we will say f of x is equal to tan x. This differentiation, you need to know a lot of topics before you can learn this particular topic. So f of x plus h is equals to tan of x plus h. Have you heard what I said? Meaning you need to learn limits, trick, and more. Even let's say this is an onwards and others rather. So tan x plus h, we'll notice that in trick, when we learned trick, we were told that tan of a plus b is equals to tan a plus tan b all over, and it was proven, not that we were just told that it is this way. The others too, same applies to the others. They were proven. So if you want how they were proven, you can follow me and then watch my trick video. I haven't dropped it yet, but I will drop it. So tan A plus tan B all over 1 minus tan A multiplying by tan B. Have you gotten that, guys? So meaning our tan x plus h will be equal to tan x plus tan h all over 1 minus tan x multiplying by tan h. Have you seen that? So that's how it will be. Then finding f of x plus h minus f of x, we will have it to be equal to tan x plus tan h all over 1 minus tan x tan h minus tan x. So notice that, guys, when you are solving questions in exam, you have to bring all those identities in order to show them that you know it to get your full marks. So moving on, to simplify this particular expression, we will have tan x plus tan h minus tan, why am I doing so? This is over 1, and we have found the denominator to be that. That is 1 minus tan x tan h. They are multiplying the two tans. So finding out that the denominator is that one, then we'll have the expression as written. That is tan minus tan x. That is, this times this will have plus tan square x, because there is a tan here, tan of x here, and there is a tan of x here too. So we'll have tan square x tan h. This one all over 1 minus tan of x and then tan of h. Have you seen that, guys? So moving forward, we will now substitute that into our first principles equation. So we will have f prime of x to be equal to lim as h approaches 0 of the whole of this tan x plus tan h, but sorry, tan x plus tan x and then minus tan x are both in the numerator rather, so they can go away with each other. So we will have tan h here now. So tan h plus tan square x plus tan h plus tan square plus tan square x tan h rather, plus tan square x plus tan square x tan h, meaning they are multiplying. See, that's how your eyes can curse you. So you have to do all the operations before you substitute everything into the function. So your eyes can easily make you make a mistake. So all over 1 minus tan x tan h. Have you seen that, guys? So this is all over h over 1. So in dividing this, you always take the reciprocal of the denominator, rational, and multiply it by the numerator, rational. So in doing so, what will we get? We will get it this way. It will be equal to it will be equal to limit as h approaches 0 of of tan h plus tan square plus tan square plus tan square x plus tan square x tan h plus tan square x tan h, then all over 1, because when it does so, it will now be all over h rather, multiplying by bracket open 1 minus tan x tan h bracket close. Have you seen that, guys? So this one will also be equal to, this one will be equal to limit as h approaches 0 of factoring tan h out here. We will have tan h, then bracket open 1 plus tan square x all over h bracket open 1 minus tan x tan h. Have you realized that, guys? So this one will now be equal to limit as h approaches 0 of tan h all over h multiplying by 1 minus tan x tan h in bracket, multiplying by all that rational, multiplying by 1 plus tan square x in bracket. So have you seen that, guys? So bracket close, another bracket close. So this is how what I'm talking about. So now moving on, we will have it to be equal to limit as h approaches 0 of tan h over h. See that, guys? Multiplying by 1 over bracket open 1 minus tan x tan h bracket close, then times 1 plus tan x tan square x bracket close. Have you seen that, guys? So this is what I'm talking about. Then notice that when you are opening an expression for a limit, it doesn't, each of these terms, it is a single term. So we don't say there are 3 terms whereby we associate each of them to the limit. No. That is, we do so when there is a negative sign or a positive sign in between the 3 terms. But if there is a division or a multiplication sign, that term is regarded as 1. Have you gotten that? So that is why we did so in the first questions we solved, but we are not going to do same here because this is a single term. Despite how large it is, it's still a single term. So it will now be equal to 1 over it will now be equal to, just applying the limit to everything, we will realize that, let's write it this way so that you see it very well what I'm talking about, so that you won't say you've not understood. So this will be Let's quickly associate brackets to each of them. Tan h over h, then bracket close. We're multiplying by 1 over 1 over 1 minus tan x tan h, then times 1 plus tan square x. Noticing this, you can apply the limit to all of them, but it's a single term. You can do so, rather. You can do so. I rushed to say you can't do so. You can do so, sorry. You can do so, but knowing that it's a single term. So applying the limit to limit as h approaches 0, but it's a single term. Notice that way. Tan h over h multiplying by limit. When you view my limit video, you see them. You can do so rather. That's forgetfulness. 1 over 1 minus tan x tan h. Then we'll have multiplying by, that is this way. Then multiplying by limit of h, limit as h approaches 0 of 1 plus tan square x. Have you seen that, guys? So this one will be 1. So noticing that that one will be 1, it will now be equal to 1 times, then substituting 0 here, we'll have 1 over 1 minus tan x, because x is not h, so we are not substituting 0 there. So tan 0, because tan h, it is that h that is approaching 0. Tan 0, then bracket close. Then multiplying by the whole of 1 plus tan square x. Why am I saying that why didn't we substitute 0 into the x? Because that one, because it is not h, it is regarded as a constant, and then tan of a constant is still that, a limit of a constant is still that constant. So limit of this constant is still that. So this one, tan 0 is 0, multiplying by minus tan x, we'll still have minus tan x. Sorry, we'll have 0. 0 multiplying by minus tan x, we'll have 0. Then it was 1 minus that expression, so we'll have 1 at the denominator. Then 1 over 1 is 1. Multiplying by 1, 1, then multiplying by this constant, that constant. So it will be 1 plus tan square x. So I would have said this is our final answer, but as a mathematician, it will not be sensible enough to leave your answer this way when you've learnt trigonometry. So in trig, we say there is one identity that says that sec square x is equals to 1 plus tan square x. So we've had 1 plus tan square x, so we can simply substitute sec square x for it. So sec square x, and that is our answer. So thank you, and then share with your lovers and enemies. Love you all. As the Bible says, love your neighbors as yourself.